Introduction to Primary Flight Control. There are three primary flight control. They are ailerons, horizontal surfaces located on wing tips. Provide roll control. Roll the aircraft to the right or left. Elevator, horizontal surface located on the tail. Provide pitch control, nosing the aircraft up and down. Rudder, vertical surface located on the tail. Provide yaw control, turning the aircraft to the left or right. Introduction to secondary flight control. To support the three main control surfaces, there are three secondary control surfaces. Flaps, a movable control surface on the aircraft wing, used to change the amount of lift generated. Flaps deflect downward during takeoff and landing to increase lift. Flaps retracted immediately after landing to decrease lift. Slats, a movable control surface on the aircraft wing, also used to change the amount of lift generated. Slats enable the aircraft to get off the ground quickly and to land more slowly. Spoilers, located on the upper wing, which, when open, decreases lift and increases drag. They reduce lift by disrupting the airflow over top of the wing. They reduce lift by disrupting the airflow over the top of the wing. They are used during the descent prior to landing and immediately after landing. Control yoke and rudder pedal. Pilot control the movement of the airplane using control sticks, yokes, and rudder pedals inside the cockpit. Control yokes. A yoke is perhaps the prototypical flight control positioned right in front of each pilot. It controls pitch, nose up and down via pull and push inputs, and roll left or right bang via left or right inputs, and may control trim as well. However, pitch and bang can also be controlled by a stick, as in some Airbus models. Rudder pedals. They are positioned on the floor in front of the pilots and act on the rudder at the tail of the aircraft. They control yaw, left and right movement via push inputs on the right and left pedal while flying, as well as steer the aircraft on the ground. Control surfaces, control and movement. Ailerons are used to roll or rotate the aircraft. When the pilot moves the stick to the right aileron moves up and the left aileron moves down. This causes more lift on the left wing and less lift on the right wing. The difference in forces causes the aircraft to roll to the right. When the pilot moves the control stick to the left aileron moves up and the right aileron moves down. This causes more lift on the right wing and less lift on the left wing. The difference in forces causes the aircraft to roll to the left. Aileron deflections are necessary for smooth coordinated turns. The combination of roll and yaw causes the airplane to lean into turns. The rudder turns the aircraft right or left. This is called yawing. When the rudder tilts to the right, more lift is created on the right, which pushes the vertical stabilizer to the left. This turn causes the airplane nose turn right. To turn right, the pilot steps on the right rudder pedals. This causes rudder tilt to the right. When rudder tilts to the left, more lift is created on the left, which pushes the vertical stabilizer to the right. This in turn causes the airplane nose turn left. To turn left, the pilot steps on left rudder pedals. This causes rudder tilt to the left. Airflow causes a force to be applied to the rudder, which turns the aircraft in the direction of force. Elevators are used to pitch the aircraft up or down, causing it to climb or dive. To climb, 1. The pilot pulls the control stick back, causing 2. The elevators to deflect it up. 3. This in turn causes the airflow to force the tail down and the nose up, thereby increasing the pitch angle as shown. To dive, the pilot pushes the control stick forward, causing elevator to deflect down. This in turn causes the airflow to lift the tail up and nose, thereby decreasing the pitch angle.